In section 5 of chapter 3, we discuss the Chebychev theorem and the empirical rule. The Chebychev theorem says that for any set of observations, whether sample or population, the proportion of the values that lie within k standard deviations of the mean is at least 1 minus 1 over k squared, where k is any value greater than 1. Let's explain what this means. For example, the average or arithmetic mean biweekly amount contributed by the Dupree Paint employees to the company's profit sharing plan is $51.54, and the standard deviation is $7.51. At least what percent of the contributions lie within plus 3.5 standard deviations and minus 3.5 standard deviations of the mean? This number here, 3.5, it could have been any number greater than 1. 1.2, 1.3, 1.7, 1.8, within 2.1, etc. You just replace these numbers 3.5 into the formula and write 1 minus 1 over 3.5 squared equals 1 minus 1 over 1225 equals 0.92. So multiply this by 100, that gives you 92% is the percent of numbers, or in this case dollar amounts, that can be found between 3.5 standard deviations on the plus side and minus 3.5 standard deviations. Let me explain this with another example. If the shape of the distribution of the data set is normal or bell shape, then we can use the empirical rule. And whereas the Chebychev theorem is a theorem that applies to any kind of shape, okay, notice that it says here for any set of observations. But if we have a normally distributed data or bell shape, and notice in this case 100 is the mean, right in the middle, and the standard deviation is 10. So plus 1 standard deviation, it will be 100 plus 10, 110. Minus 1 standard deviation will be 100 minus 10, will be 90. So within 1 standard deviation, we find 68% of the data. Within 2 standard deviations of the mean, which will be between 80 and 120, 100 plus 20, 100 minus 20, you should find about 95% of the data. And finally, within 3 standard deviations, we find about 99.7% of the data. Notice how the percent of the data is increased if we assume a normal distribution. Under the Chebychev theorem, within 3.5 standard deviations, we found at least 92% of the data. So the threshold is lower, much lower, because in the empirical rule, only within 3 standard deviations, we are expected to find 99.7% of the data. Let me give you an example for the Chebychevs. It is said that the standard deviation is 751 and the average is 51.54. So if we add 7.51 times 3.5, that number, then we get what? Well, I have a calculator here. We will obtain 51.54 plus 26, sorry, let me erase this, 26 29. And 2629 plus 5154 equals 7783. And if we take 5154 and subtract 751, time is 3.5. What is that equal to? Well, it'll be 5154 minus 2629. So in that case, it'll be 2525. So it is expected that at least 92% of these values will be between $25.25 and $77.83. Now, like I said before, you could have used the Chebychev theorem to find anything else or any other percentage. For example, we know using the empirical rule that within 2 standard deviations we find 95% of the data. What percent of the data do we find using Chebychev's theorem within 2 standard deviations? So using the formula, it'll be 1 minus 1 over 2 squared. It'll be 1 minus 1 over 4. Well, that is 3 over 4. 4 over 4 minus 1 over 4. And that is 75%. So notice that the percent is lower because Chebychev applies to any shape. So the numbers are more conservative. So that's the end of section 5 and the end of chapter 3.